right. Well, good afternoon, everyone. Thank you for everyone joining us today. Today, we're going to be talking about post-frame construction. This is what we're going to be looking at learning today. So this is what we'll cover. So focusing on the envelope, recognizing that post-frame construction buildings may be often dealt with just in dealing just with the envelopes and may not include the rest of the buildings or the building systems. So focusing on the envelope, recognizing as far as when building pressure testing is required and how to conduct that at different times, and implementing design choices for that building envelope. So as far as who we are, we're the Smart Energy Design Assistance Center. We're housed at the University of Illinois in conjunction with our private partner, 360 Energy Group. And our mission is to reduce the energy footprint of Illinois and beyond. And these energy code trainings are one way that we accomplish that mission. So we are an applied research program at the University of Illinois, and we seek to assist buildings and communities through energy efficiency to save money and become more sustainable. So that includes through education, research, and advocacy for a greener future. Our energy code training is made possible through the Illinois State Energy Office that is housed at the Illinois Environmental Protection Agency, and we do appreciate their support of our program, that we're able to provide this training at no cost to you today. We do have a technical support program through the Energy Code Training Program. Our email address is energycode@illinois.edu, and we do have an 800 number, 800-214-7954. Just in case you do have just a quick question, where is this located in the code, or that, you can use that 800 number. Otherwise, we encourage people to use our email address, energycode@illinois.edu. This allows our team to provide a written response back to you for use for you and your whole team. That also may be useful as part of dealing with code officials, and as they're able to also see that, have that same information in a written format. We do have several online resources on our website, smartenergy.illinois.edu/energy-code. And some of those resources include archive versions of our workshops and webinars, as well as several online on-demand training modules. Our workshops and webinars generally offer continuing education credits for those who participate live. The recordings do not contain those. However, that's where these on-demand training modules can come in handy. Those do have continuing education credits attached to those for your assistance. So Illinois Energy Conservation Code is one of a handful of codes that is adopted at the state level. Many of the building codes may be adopted at the local level, but the Illinois Energy Conservation Code is adopted by the state of Illinois. And that went into effect for permit applications beginning January 1st of this year. So permit applications prior to that date would have been under the would have been following the 2018 IECC. Also noting here on the screen, Illinois has worked with the International Code Council to publish a state-specific code book that also includes and incorporates the Illinois-specific amendments. So rather than using the 2021 International Energy Conservation Code along with the a handful of amendment pages. This provides it as a single document, and that is available on their website now. So there is noted, this is very helpful. The International Code Council does provide free view-only access to all of their codes, and the search or find function works very well on their website for that. So the slides of today's presentation will be made available on our website following today's session. So don't have to worry about remembering to write down all the links and addresses, or you can come to our website and find these direct links as well. So along with that, jurisdictions may provide additional amendments that increase the stringency for commercial buildings. And one of the largest jurisdiction in the state, the city of Chicago, has done just that. And so they have the Chicago Energy Transformation Code, which is the Illinois Energy Conservation Code, with a few additional amendments above and beyond for that. And they have provided a comprehensive publication as well. So first thing to be aware of is understanding if you're dealing with residential or commercial buildings. Understanding that post-frame construction is not limited just to commercial, but may also be residential in nature as well. And so understanding what a residential building for the Illinois Energy Conservation Code means a detached one-family or two-family dwelling, or any building that is 3 stories or less in height above grade that contains multiple dwelling units in which the occupants reside primarily on a permanent basis. So that is slightly different than the International Energy Conservation Code, but again, making sure that you understand, are you in a residential building or a commercial building? Fortunately, the Energy Conservation Codes makes it fairly simple as far as what's a commercial building. It's anything that is not residential. So you can have group R or residential occupancies inside of a commercial building, but as part of the code, just understanding, are you in a residential building or a commercial building? We will also be touching on the various provisions, both commercial and residential, as there are similarities as well as some differences between those. So the post-frame construction, understanding that these are typically using posts or columns spaced every 8 to 12 feet on center. These could be wood posts or metal, and then using pre-engineered roof trusses or beams of that sort of a similar material for metal buildings. And so these, just making sure that people are understanding what a post-frame building is. So some things to be aware of is there is definitely some performance improvements for post-frame over traditional stick frame construction. Some of this is because while the posts may be larger due to their substantially larger or wider spacing between the posts, there is a lot less thermal bridging, and thermal breaks can also add and enhance some of the insulation values for that. So they also have the ability, because they're often dealt with in sheet goods, have the potential to reduce and minimize the air leakage and thermal bridging for that. And with that, insulation may also be able to be wrapped more continuously across the various areas. So with that, I'm going to turn it over to my colleague, Nana Duncan, to touch on some of these provisions.
Hi, good afternoon. My name is Nana Duncan, and thank you so much, Ryan. So I'll just build up on what Ryan has already talked about, and I'll hand it over back to him to continue with that, and I'll dive into the related provisions in the 2021 IECC with respect to post-frame constructions. Right, right. So okay, so I start off with the minimum R values. We took excerpts from the table C402.1.3 from the commercial side and 402.1.3 also from the residential side. And basically, we are looking to show exactly what a minimum R total R value for the walls are, and for other components as well, not just entirely the walls, but also roofs, as you can see. In this particular case, we picked just climate zone 4 and 5. And for the same thing happened here for climate zone 4 and 5 for the commercial and residential aspect of it. And then so let me just dig a little bit into what all these figures that you probably see there means. When you take, for instance, when you see the wood frame and the other side of it, and you're looking at group R wood frame, climate zone 4 except marine, you can see that we have R13 plus R3.8, which is the continuous insulation. So you have the option of taking R3.8 cavity insulation in addition to R3.8 continuous insulation, or you can do entirely a cavity insulation and then just go R20. And a similar idea applies here on the residential aspect of it as well. It also has climate zone 4, except for the marine. You can do for wood frame walls, you can do about 30 cavity insulation R30, and also or you can do R20, and then you add a continuous insulation of R5. So basically that is what it is. It's telling you about the thermal resistance of the materials that you are using. But there's also an alternative that you can use, and that alternative is to use the maximum U factors, which is more or less it's all summing up to the same point, but then it's looking more about the total wall assembly as similar to what I was talking about previously, more about the total wall assembly. How much the point is arriving at the same side, because it's all dealing with how much heat is able to come through. So in this particular case, unlike the R values where we talk mostly about what it was for the, it being higher, the better. In this particular case, it's being lower, the better. And so as you can see, if we take, for instance, in climate zone 4, except for marine, and you go the wood frame, and for all others, you can see that there's a maximum requirement of 0.04664, and that is the maximum that you should go. And you would normally want to do a lot less than that to be able to have an enhanced envelope. And so it's a similar thing with the residential aspect of it. If you pay particular attention, you can see that some parts of it are highlighted in blue. And those ones are, I would say, the most recent revisions that were done to it from the 2018 to the 2021 part of it. So usually when you take the IECC, this is something that you would also want to pay attention to, especially if you are looking at revisions. And also you can see the ones highlighted in red. These are the Illinois provisions. Sorry, Illinois amendments, I meant. And so you'd want to pay a lot more attention to that as well. So you can also see the differences between the tables that we have there for the residential and then for the commercial. You can see that the components in some cases look a little bit different, because if you take a closer look, over here we have the ceiling U factor, we have the U frame wall U factor, and then the mass wall U factor. It's not everything that is on that the particular components that are observant in the commercial side that would also be in the residential side. It differs a little bit. So even though it's all arriving at the same point, I just wanted to point out that it has very different things as well. So these are also the fenestration, and it also has to do with the U values. And in the same way, we are comparing what it is in the C402 4 against what it's supposed to be in the residential aspect as well. We are setting specific limits on the fenestration area as a percentage of the gross wall area. So in this particular case, you can find the U factors, the solar heat gain coefficient, and then the skylights as well, which we'll dig more into later. So that is for the part of the commercial, and then we can compare to the residential as well. You can see a little bit of differences in there. You can determine that with the commercial aspect of it seems a little more stringent than when you compare to the residential aspect of it. And in fact, as you can see, you do not even see the skylights aspect of it so much when you compare the U factor for the skylights in climate zone 4, except marine. When you compare that, you could tell that what it is for the residential aspect of it is a little bit higher than what is supposed to be for the commercial. So that is also a little thing that you would want to pay some attention to. Okay, so we also move on to the air barrier requirements, and this is just a summary of everything. We'll go deeper as we move ahead. So this is also the materials, and it tells us about, we summed it up to the materials that you can use for the ceiling and exactly what the practices should be if you want to minimize the leakage, whether through openings, cracks, and exactly how to put the air barrier to prevent moisture and other things as well. So as you can see, I talked a little bit in the beginning about continuous insulation. So that continuous insulation is what you may be observing here in the diagram that we have here. And so based on that, you have you can create your air barrier as well. The location is very much important depending on what you seek to achieve. So you would want to pay a little more attention to the location, which you can dig more into at section C402.5.1. And also, if you're looking to minimize the air leakage through the fenestration, you'd want to pay more attention to C402.5.4. Okay. All right. Okay. So as I mentioned a lot about the air barrier, I talked about the summary, the requirements that we had. This digs a little more into the construction. And these are, I would say, I usually would put it as these are the very essentials that you would want to pay, more and more attention, because as you move forward, that you would have to do the air barrier, the verification of the compliance. You'd want to ensure that all the openings or some cracks that you may have, you have perfectly sealed them, so that when the blower door testing, which we are moving on to in the next slide, is done, you would have, be meeting the exact requirements that you're supposed to meet. So as you can see here, that it's denoted in bullet points that you have to use caulks, you have to use gaskets or other sealants that are compatible with materials and location. So like I mentioned, based on the location as well, you would want to put into consideration the exact type of sealing and materials that you want to make use of. Right, so this is the blower door test that I just mentioned or talked about. And this applies in both cases, either for commercial or for residential. As you can see that we have right at the top for C402.5.1.2 and .4 on R402.4.1.2. That is for the residential aspect of it. And in this particular case, we are dealing more with the buildings or spaces that includes group R. And whenever you hear these group R and I, we are technically talking about the commercial aspect of it. And that we are saying that it shall meet C402.5.2. These are requirements that we'll move into deeper into the next slide. But basically, it's going to tell us about the dwelling and sleeping unit enclosure testing. And then for spaces, building or spaces other than group R and I, you would have a different requirement that you would want to meet. That is also for the building thermal envelope testing as well. So one very important point that you want to make, put at the back of your mind is that based on what we have just said, it can tell you that all commercial buildings in Illinois must be pressure tested. And as I mentioned earlier, if you're also looking to do the residential aspect of it, you would want to go through R402.4.1.2. basically, it is always done for the residential aspect of it. And so you'd want to pay more and more attention to that as well. Okay, so one thing that I wanted to, based on that is coming back to the point that I just left for the air barrier, the blower door testing that I just talked about. Illinois is particularly, it's required that you test it all the time. And moving on to the slide, you can tell it from here. These are the exceptions that are given, and it's obvious that the Illinois state is not part or within these climate zones. That is 2B, 3C, and then 5C. So these are climate Illinois falls into, and that in putting that at the back of your mind, you'd always want to make sure that anytime you're dealing with buildings that are located in Illinois, blower door testing is a requirement that you must follow. Okay, so C402.5.2, that is also the dwelling and sleeping unit enclosure testing. And as I mentioned earlier, if you oh, sorry about that. It seems like the internet. Okay. So, hi, am I audible?
Yeah, the audio is coming through.
Hello? Am I audible?
Yes, we can hear you.
Hello? Oh. Okay, all right. I just wanted to make sure that, because I could tell that my internet was, having issues. Then I would take us back to, I think I flipped it too fast. My internet was having issues. No. Hi. Right. So sorry about that. My internet is giving me a very tough time. I don't know exactly why it's happening at this time. Okay, so I believe that when I spoke about the blower door testing aspect of it, I was very much audible and I was heard. So if not, if I wasn't heard, I could take it again, or I'd like to go straight into C402.5.2. That is for the dwelling and sleeping unit enclosure testing that I mentioned previously while I was talking about the blower door testing. So in this particular case, you would want to make sure that you're measuring the air leakage not to exceed 0.30 CFM per square foot of testing unit enclosure area at 0.2-inch water gauge. That is 50 pascals. So in this particular case, that as you're looking at it, we are dealing with the dwelling and sleeping unit enclosure testing, which will move into the building thermal testing as well in the next slide. And these things that I'm talking about, these measurements that we are referring to, are usually being done using the blower door testing. I just wanted to give you what the correlation is. Yeah. Okay. Right. So sorry about this. I don't know what exactly is going on with my internet. So for C402.5.3, we go into the building thermal envelope testing, and that also has a different requirement, and you'd want to make sure you're measuring the air leakage not to exceed 0.40 CFM per square foot of the thermal envelope, and area at 0.30-inch water gauge. That is 75 for the whole building test in this particular case. we are talking about the commercial buildings. So you want to pay particular attention to that. And this is also the last bullet point that is right down here, is one that I would, usually emphasize a lot more on, that if the total leakage is between 0.40 CFM per square foot and 0.60 CFM per square foot, it's allowed to complete the diagnostic testing and non-destructive remediation without additional testing. And you must submit report for the corrective actions. Seems like my internet is dragging. Ryan, can you help out with moving to the next slide? Okay, thank you. All right. So C402.5.1.5, and we are going into the building envelope performance verification. And like I mentioned, the blower door testing or the compliance verification, it's always needed. You'd always have to do it for the residential, but particularly when you're looking at the commercial, you'd always have to look specifically at the segments that you are looking to test. And if you are looking at the air barrier installation shall be verified by the code official, registered design professional, approved agency per these following bullet points that I have here. And that is one thing, that who can actually do the blower door testing, who is the approved person. And the very simple and straightforward answer, I would call it, is that person who is actually approved by the code official. And that is how you'd want to put it. Right. So this is for the residential aspect of it. I believe I've spoken a lot about it in the previous slides, and I'll just touch on it one more time, that you'd measure air leakage not to exceed 3 air changes per hour at 0.2-inch water gauge, that is 50 pascals. And once you hear the 50 and the 75 pascals, you should use that to determine what the difference actually is. One is looking at the commercial aspect of it. The other one is out actually taking a closer look at the residential part of it. Okay, so we're going to go into the operable interlock, and we're looking at this also for the based on the fact that the shell, there could be instances where the contractor is only dealing with the shell, and then whoever is working on the equipment side is also a different contractor. So this point is particularly very important, because you'd want to make sure that whatever you're doing in the shell, you're also doing things that are not going to make the job of the other contractors too difficult. Like we mentioned in the beginning for the objectives, one of the objectives is to be able to see how all the contractors on a single project can cooperate and make the project more successful. So as you can see here, I'll just point out to this door hinge that you can see there. The requirement that is listed here is that the conditioned space with doors that have an opening area of greater than 40 square foot to the outdoors must be equipped with controls that adjust the HVAC settings when the door is open. So you'd want to make room for this particular thing. And this usually, of course, would not be done by the shell creators of the shell, but actually those who work on the equipment. So you'd want to make room for them to be able to do that as well. And then we come to the load calculations and the sizing. And C403.1.1 is telling us basically how it's supposed to be done for the commercial, and the commercial side of it, the load sizing, and C403.3.1. And then it's also telling us about the specifics that how you'd want to, the design that you would want to pick. The other part is telling us about the calculations. And if we were dealing a lot with the residential, we'll be looking at the manual J and then the manual S in this. So basically the takeaway point at this particular slide is that we are looking at the fact that if you are building, putting up something with, a very good and envelope, an enhanced envelope, that you would want to make sure that if you created just the shell, you are telling the client that, hey, this is a building that is performing very well. It has a very great thermal performance. And so you would want to make sure that your load calculations are not, figured as the very normal building. And so you'd want to factor these things into your points. All right, so this is also for the skylight area. I believe I've spoken a little bit about it, but I'll touch on it a little more. And most important point that I want to touch on here is that, just as we spoke about it and it was listed in the commercial aspect of it, it's not supposed to come across as a requirement for all commercial buildings that you are working on. But then there are specifics that, you'd want to pay attention to. And those specifics includes that if you are dealing with enclosed spaces that are greater than 2,500 square feet in floor area, directly under a roof, with not less than 75% of the ceiling area, with a ceiling height greater than 15 feet, then, and it's an office, it's a lobby, an atrium, concourse, a corridor, then you would be required to follow and get a skylight. One more exception that I wanted to point to, and then the exceptions actually with buildings in climate zone 6 through to climate zone 8. So that is what it says here. Skylights above the light zones of enclosed spaces are not required in climate zone 6 through 8. So these are the additional efficiency requirements that I would also want to touch on. These are, it takes into account the different climate units and occupancy types. As you know, I mentioned some of the occupancy types. I talked about the R and then the I. These are 15 additional energy efficiency options that you can choose from and get some credits. And the minimum credits that you can achieve for compliance is 10 points. So in this particular case, we focus more on the enhanced envelope and then the reduced infiltration. That is where we deal more on. We look at more in this particular presentation. And so we look at it a lot more, and that is C406.8 enhanced envelope. You are supposed to do 15% better of the UA, and the UA is basically the the U factor, and multiplied by the area that you are dealing with. And also we are looking at the C406.9. That is the reduced infiltration. These are the requirements that we talked a little about in the beginning when we're dealing more about the blower door testing. And as you can see, we're dealing with the commercial side. And you could note that the reduced infiltration, we are mentioning that it should be done at 75 scales. So basically, that is the understanding of it. The benefit of it is that if you're able to do this, as we mentioned, going back to the point about load calcs and all of that, you are building the building to be, performing way, way better and not putting it on the standard of a normal building that, whoever is working on the equipment side as well would also have to put that into account and do a proper sizing. So the additional efficiency requirements, so the different climate zones and then the groups and what you can actually achieve. So as you can see that if you're doing an enhanced envelope performance, that is C406.8, if you are in climate zone 5A and you're doing group B, you can actually pick just a single one of these and you are able to achieve the minimum of 10 points and you are in compliance with what the requirement is. You could also work further and do, a lot more, as we mentioned. These ceiling and air barrier stuff that things that we talked about, you can actually pay more attention to that and get extra points of 11 and earn a total of 21 points. You can also do the same for climate zone 5A for group R and I, which you can achieve 13 points. So as you can see here, the only side that you can actually pick just a single aspect of it and achieve the minimum that you're supposed to achieve is climate zone 5A group B. And for specifics like climate zone 5A, it's obvious that it would not be able to get you through if you even combine even the two factors. And that, I believe, is the education part of the construction work. So you would want to pay some attention to this if you want to achieve these points, especially when you're working in climate zone 5A, group B. It's something that enhance envelope performance and reduce infiltration. You would want to pay attention to them very much and get the points. Okay, so this is the thermal envelope certificate that at the end of the day you should have, and this is very much important. As you can see, it actually documents everything, all the insulation, the fenestration rating, and the leakage test that we have on there. In this particular instance, as only the shell could be done by a particular contractor, and then some other aspects of it also be done by somebody else. This is very much highly important that all these documentations are done, that, you know, when another person comes to work on the construction, they know exactly what went into the building, even at the very initial stage, that when there's a necessary time to do some more retrofits, it would not be too much of a big deal for a completely different contractor. Right. So it brings us to the close of my presentation, my aspect of it, and I'll hand it back to Ryan to take us through.
Well, thank you.
Right.
Yep.
And then there comes a poll question.
Yeah.
So
we have a poll question here, and the question is, what could C406.8 and 9, enhanced envelope and reduced infiltration, affect the most? Choose one: heat pump sizing, lighting efficiency, or indoor air quality. We'll give people a moment to answer that. And while you're working on that, a couple of other notes as far as if you are using a link that's from someone who's not you, or you are watching this presentation in a group, would ask, go ahead and put your name and email address into the question and answer box and submit it as a quote question. That way we'll be able to record those. Also, if you do have any questions as we are going through this presentation, do go ahead and use that Q&A feature. You'll probably see it located towards the bottom of your screen. It'll say Q&A, and you can go ahead and put your question in there, and we can answer it either through the course of the presentation or at the end of that. So again, do go ahead and use those, provide those questions if you would. All right, looks like most everyone has gotten an answer. Got a couple more coming in here. We'll go ahead and end that poll. All right. So which is going to be impacted the most from using an enhanced envelope or reduced infiltration? Looks like most people picked up on this. Heat pump sizing. Lighting efficiency doesn't get impacted by the envelope directly. And indoor air quality, that is definitely a side effect, but for the code, heat pump sizing would be the correct answer. So I'm glad no one picked lighting efficiency out of that. All right. So looking at compliance and how do we demonstrate compliance? So there's a couple of paths. We're going to focus starting on the prescriptive path. So the prescriptive path is kind of like a grocery checklist where you go through, and if you've gotten all the items on your grocery list, then that is a successful trip. So here being, if you follow the prescriptive path, you're going through component by component. So we've got our envelope components, mechanical, service, and lighting, along with the additional efficiency options. So as Nana talked about, projects in the commercial space have to get additional efficiency options. That's also the same for residential. And so picking those up as you go along, and as Nana mentioned also, if you do pick up those those additional efficiency options as part of your building design, you want to make sure that your client knows to pass that information along if the mechanical system is not being provided by the same under the same project, so that they can make sure that they have incorporated and accounted for that improvement. So the code also has the ability to do a UA trade-off or U-factor trade-offs, also known as the component performance alternative. So if, for instance, you'd like to put in better performing windows than the code requires, and you say, well, because I'm putting in better performing windows, I want to be able to reduce how much insulation I have to put in the roof. So some things like that, the code does allow you to do some trade-offs across your envelope, such as that. That might be a good one if you do say, well, let me not want to insulate the roof quite as much, but I'm interested in putting in better windows, because windows are often the weak point in an envelope. So commonly this is going to be done, shown using a ComCheck or ResCheck for this. ComCheck and ResCheck are really doing that U-factor or that UA trade-off, or that's what they're doing, their comparison. They do allow you to provide or produce a report for just the envelope, and acknowledging if your project is just going to be for the envelope and mechanicals and lighting and the other systems are going to be dealt with by someone under a separate contract and under a separate project, then you're going to need to pick up the additional efficiency measures for that on the envelope side, such that the HVAC and the lighting is allowed to be the code minimum standard. So someone has to have picked it up. So in order to do this, you're going to have to probably show it as part of the envelope. So as far as what that looks like, the air barrier. So again, if we're in Illinois, we're going to be doing the air leakage test for that. And for those areas that for commercial buildings, larger commercial buildings, you may not necessarily have to test the entire building. The code does provide alternative performance verification methods for the sections of the building that are not being air tested. But in this case, we're going to go ahead and assume that we are doing air leakage testing for this building. So when filling out a ComCheck, recognizing that ComCheck doesn't have post-frame construction, at least for wood frame buildings. They do for metal post-frame buildings. That's just called a metal building in ComCheck. So if we're doing a wood frame building, we would go ahead and call out wood framed. We're going to say that the studs are 24 inches on center, because with a triple stud column or triple stud post being 8 foot on center, that's effectively a 32-inch on center stud, is a similar or equivalent spacing for that. So for ComCheck, we'll go ahead and pick wood frame construction, 24 inches on center, because it has either 16 or 24. 24 is as close as we can get to these buildings. And if anything, this is going to understate the performance by selecting 24 inches on center. And going ahead and putting in how much cavity insulation and how much continuous insulation are we using for this. So in this case, we're saying we're going to use an R21 cavity. So that's between the post frame. What's that cavity? And the continuous insulation is what's the value across that is continuous across the entire building. So not both in the cavities and also where the posts are. So that if that insulation goes all the way across the whole building, that'll be continuous. for that. So here we're just assuming an R21 cavity and then a 7.5 continuous. So some things as far as going through, there is an opportunity out there is understanding a ComCheck doesn't have wood post frame buildings built into the software. There is a capability in here to do custom inputs where you can say it's a custom wood frame structure and you can enter what is the U factor of that assembly. So you can calculate it and go ahead and enter that. Now, we will say that if you do go ahead and just enter custom U factors, you need to make sure that you are providing your calculations to the code officials. Otherwise, that's likely to be a real quick question back from them. They'll go back and say, I see custom U factors. I need to see the calculations for that. So this might be an easier method, is just go ahead and use the 24-inch on center wood framed walls, and then go ahead and just put in your R values for cavity and continuous insulation, and let ComCheck go ahead and do that calculation for you. Again, recognizing that this is going to, your real actual wall is going to be slightly better performing than ComCheck is going to be modeling this. So when we get to the credits, going through and checking off and identifying, okay, what are we going to make as far as our ComCheck? So here we have selected both envelope 4068 and 4069, and then we need to enter what is our CFM per square foot that we are going to be using. So whether that's just the code minimum value of 0.25, or are we going to do better than code minimum and go to 0.2 or 0.15? So that is a possibility out there. Well, again, this is all under the prescriptive compliance path that we're doing this. For those of you that may have picked up as Nana was presenting, so for commercial buildings, for envelope testing, 0.4 is a pass without additional non-destructive remediation. If you are above a 0.4, then you may need to do some non-destructive remediation. If you're above a 0.6, which we're getting pretty leaky at that point, then you may have to do destructive remediation, or you might be able to do a non-destructive remediation and still do a retest for that. So, but in order to get this reduced area infiltration, I got to get, instead of a 0.4, I have to get 0.25 or better. So as mentioned earlier, ComCheck does allow you to do an envelope compliance certificate. So this is what you would provide if all your project is just to do an envelope. You can provide a completed ComCheck certificate, and you'll notice here it calls out very similar to what the software showed earlier when we were doing the data entry. You know, my R21 cavity along with my 7.5 continuous, and then so it's going through and checking that the your proposed is at least as good as the budget. So here, because we're in climate zone 5A and we had selected an office, which is a type B. So here we said, okay, envelope, we're doing enhanced envelope performance. So we get 10 credits for that, and reduced air infiltration. We're getting 11 credits from that. So here we're showing we are getting 21 credits of the minimum 10 we needed. So this is going to be very good as we're going through that. Well, and that's something that if you are doing something that is alternative to or better than stick frame construction, again, making sure that people understand that, where you're getting that. So that's the prescriptive path. Another option out there is performance path. So this is where you do building energy modeling and comparing what is it that I'm proposing my building to be versus what is the code allowed building to be. And so gets to be a little bit more complicated because here we have to have two building models, again, our proposed and our code minimum. And there is a couple of tables in the code, one for commercial and one for residential, that state here are what the criteria for these different buildings need to be. As far as for this model, do both of them use the same input, or are you allowed to have a difference between the code minimum and what your proposed model to be? So some things that might be the same in both are going to be things like square footage, the orientation of the building schedule. So you can't say, well, normally this office building would be open, 80 hours a week, but I'm going to propose that I only have this office open 20 hours a week and try to take credit from all those hours that it's not operating. So it calls out that, the schedules and that they need to be the same for both your energy code model as well as your proposed model. So eQuest does have an extra feature in there for Appendix G. Just like to call that out. So if you are using that, it's perhaps less common, but there are some various software requirements that need to be met as far as if you're doing performance building energy model. Some of the more common softwares that do these, eQuest, Safaria, Energy, and Energy Plus. So, and this is for commercial, and there's similar ones for residential. If you are doing residential, there is also an ERI path. So this is another performance type path. This is related very closely to the a HERS rating. However, there is some slight differences between a HERS rating and an ERI compliance report. So they should any HERS rater should be able to produce this as well, since the softwares are overlap between them, and they would have the capability and capacity to do that. So some of the most common ones we see are Ecotrope, Energy Gauge, and REM rate, along with REM design. So the ERI is slightly different than a HERS rating, but they are very similar. Also, if you do have projects in Illinois, if they are considering pursuing Passive House certification, that is deemed to be code compliant for the state of Illinois. So that may be an option if you are doing a state of Illinois project that are looking to do Passive House. So as far as post-frame construction, recognizing and acknowledging some of the differences between post-frame versus stick frame construction. Some of the insulation techniques can be much more optimized, and because oftentimes really relies on sheet goods, can reduce several of the seams that may make testing easier to perform. Also, something to note for testing, residential is required to be tested for new construction, where commercial is required to be tested for new construction along with additions and envelope alterations. So something to be aware of. That's a little difference between commercial and residential there. As far as looking towards the 2024 IECC, we are seeing some of the more system controls being required for smaller and smaller units. For those, if you do have some alterations, probably not too many for post-frame construction, but when you are doing replacement HVAC equipment, there is requirements to raise the roof curbs to accommodate future increases in insulation for low slope roofs. Also, if you have electrical boxes penetrating that air barrier, wherever your air control layer is, those are going to have to be listed and rated airtight receptacle boxes, similar to airtight cans, where they have to be rated and listed as air resistant. So Nana mentioned earlier, that air control layer can go towards the inside or to the outside of the assembly, somewhere within the assembly, or to the inside. This airtight receptacle box may be a reason why you might want to consider locating that air control layer towards the outside of that building to minimize how many of these airtight boxes might be needed. So we don't see this used too often, but it is an option to use ASHRAE 90.1 in lieu of the International Energy Conservation Code to demonstrate compliance with the code. So this is an option to use 90.1 versus IECC. Probably the one reason why we see people that use ASHRAE 90.1 is it has a space type called semi-heated, whereas the IECC spaces are either conditioned or unconditioned. So if you are in one of these spaces where it might be just semi-heated, ASHRAE 90.1 might be an easier method to comply with. So with that, do we have any other questions that people may wish to ask that we might not have answered so far? And you can reach out to us at energycode@illinois.edu. So if you do think of a question afterwards, or you have some questions regarding projects that you are working on, feel free to reach out to us, and our team works to get back with you fairly quickly. Seeing no other questions, I want to thank everyone for joining us today. And on behalf of Nana and myself, thank you so much for participating, and have a great afternoon.